Good. Same test, but on the spindle itself. Also good. Yeah, should be roughly within 1/100th of a millimeter, which is little bit less of that. I'd say this is within that. So this is the top of the test bar, and I move it. It goes actually a little bit below and up again. And it's within, I'd say, 3/10,000ths there. Went a little bit the other way, so, but it's up. So let's say within 1/100th of a millimeter up. That's also okay. And then it's the test from the front, which of course should read 0, but can also read a little bit towards the operator, I mean, to compensate for tool pressure. So if I 0 it here, go in, there. Now I move it to the side. It goes a little bit towards the operator, yes. See? So I'd say that is 5/10,000ths, or a little bit over 1/100th of a millimeter, which is okay. And the spindle taper run out. Okay, so I'd say it is 1/200ths, which is 6/10,000ths, which is also okay, at the limit, but okay. And this is another test of the accuracy of the lathe and its ability to turn or to face. And it says in the spec sheet that it shall face concave up to 5/10,000ths of an inch at 3.5 inch out on a 7-inch faceplate, that is. So if you think about it this way, I've clocked in this reference here, so that it end to end measures the same, so to speak. If we go out here just to 0 and rotate, I have 0. And then when you face concave, that means that if you have 0 here, then that when you go inwards, and I am in metric, so I'd say 1/100th of a millimeter. It's a little bit shy of 5/10,000ths. So I go towards the center. And it's, well, it's less than that also. Could be bit, as you see. So go back again. Yeah, it's roughly 1/100th of a millimeter. As you see, in that direction. So all good. And the way that I have adjusted is by scraping on the rear here, and as you see, I try to also to relieve the middle a little bit. I've liberal blue on now just to show, but this is how quite simply you do that. I think that Myford also did it that way. They could have done it on the longer way here, but anyway, that's the way I did it. And this is one of the accuracy tests for the lathe. So it should be 0 to 2 to 300 of a millimeter higher at this end to travel along the length here. So I've zeroed the indicator at this end, and I move it. And it went up by 1/100th of a millimeter. The full travel here. So go back and just check that it repeats, and it does. That was one test, and this is the same test as longitudinal feed. I mounted the camera from pointing downwards at the rear of the machine, so this is pressure towards me here. I can of course adjust this error out, but this is a proof that the longitudinal, let's say, axis, I adjust it there, is okay. And this is also a proof on the cross slide feed. I set it up with backlash around 2/100th of a millimeter. So I run towards the tailstock. As I said, this error, if any, can be adjusted out, and now I'm using the hand wheel. And I am at 1/100th of a millimeter. There. So, and that was to the rear, but it's within, 1/2 and I can of course adjust this out by adjusting the screws at the rear here. So that also proves within. And this is another test for the tailstock, saying that the tailstock barrel, the travel along the barrel shall be from 0 to 0 and possibly a little bit up, like 2/100th of a millimeter up. Within that, it shall not dip below 0. That we allow, then we allow for a little wear and put it so that it goes a little bit up. So we run the indicator here, and it's roughly 1.5 higher here. So that's okay. And the same test from the side. I had to run this from the front because there's a slot in the rear here, but it shall be 0 here and pointing towards 2 pressure, so pointing a little bit towards the operator when we move to the headstock. So I apply pressure, so that means that plus is this way, and then I move towards the operator, so it goes a little bit plus, so around 1 to 1.5 to me, so that's okay. One of the accuracy tests